Hello everyone, welcome to this next video on complex analysis. In this video we shall take up question from GATE 2010, and so the question is from Laurent series. They are saying this summation n varying from minus infinity to plus infinity bn z raised to power n be the Laurent series expansion of this function. So this is our fz, right? And this is only defined, the magnitude of this function is only defined between the point 0 and pi. So it does not include 0 and the point z is equal to pi. Then they are asking which one of the following is correct. So here the thing that we have to do is we have to look up what is the Laurent series expansion for the given function f of z is equal to 1 upon z sine hyperbolic z. So for that, let us quickly have a look at this expansion. So the Laurent series expansion of any function fz about the point z is equal to a. Suppose this is our point a, then we can draw two circles, one with radius r1, call that to be c1, and another with radius r2, right, call that to be c2. So these two circles, they are positively oriented. So what we do instead, we define our function in this region and say this is analytic in that particular annulus region between c1 and c2. Moreover, the function is single valued. In that case, this expansion is written like this: a0 plus an z minus a plus a2 z minus a square plus up to infinity, and then we have these terms in the denominator. Moreover, this part is known as the analytic part and this part is the principal part corresponding to our series, right? So what are these? a0, a1, a2, a minus 1, a minus 2, these are the coefficients which are calculated using this particular formula. So here also what we have to do, we have to expand our function in terms of this kind of series. So let us do that. Our function is defined like this. Here sine hyperbolic z is appearing. So we know by definition this is equivalent to e to the power z minus e to the power minus z divided by 2. So if we substitute the value of sine hyperbolic z onto this function, we would obtain f of z. This is equivalent to 1 upon z and the value of this whole thing. So e to the power z minus e to the power minus z upon 2, right? So we can simplify this. So what do we get? We know the expansion for e to the power z. We know this e to the power z, that is basically 1 plus z square by 2 factorial plus z cube by 3 factorial and so on, right? So similarly, e to the power minus z's expansion would be 1 minus z plus z square by 2 factorial minus z cube by 3 factorial plus so on, right? That means you have just replaced z by minus z in this series. So using these two expansions, we can write this to be 2 by z as such, and then here in the denominator, we would have this whole series minus this series. So when you subtract this series from this, when you subtract these two, what would you obtain? This 1 and 1 cancels. So you would have 2z, right? So 2z, and then we would have this term and this terms would cancel. So we would have plus 2 times z cube by 3 factorial, right? And then the next power 4 term would cancel. Then we would have z power 5 upon 5 factorial and so on. So in every term, you see we have a 2 and we have a z. So we can take this 2z common. So we would have 1 plus z square by 3 factorial plus z power 4 by 5 factorial and terms like that in the denominator. So from here this 2 and 2 cancels. So we would have something like this: 1 by, now this would be z square, right? So 1 by z square, and then we would have 1 plus z square by 3 factorial plus z raised to power 4 by 5 factorial and so on, right? So again we can write this to be 1 plus this whole term z square plus 3 factorial z power 4 by 5 factorial and so on raised to power minus 1. That means I have shifted this term which was in denominator upwards in the numerator. So now we know the expansion for this thing, 1 plus z raised to power n using the binomial theorem. So it would be 1 plus nz plus n minus 1 by 2 into x z sorry, it was z, so it would be z square and so on, right? So we can use the similar expansion over here for this term. So let us see what do we obtain. So we had this thing, this term, right? So it would be 1 by z square as such, and then we would have 1, and instead of n we have minus 1, so it would be minus this whole term z square by 3 factorial plus z power 4 by 5 factorial plus so on, right? And then we would have plus the square of this term, right? So n here is minus 1, and then we have minus 1 divided by 2 into z square. And what is z square? This is our z. So it would be z square by 3 factorial plus z raised to power 4 by 5 factorial and so on, right? The square of this term and terms continuing like this. So if I write this whole thing here, so what do I get? It would be 1 by z square, right? And then here you would have minus 1 into minus 2 upon 2. So basically this term overall, this becomes 1. So we would be left with 1 minus z square by 3 factorial plus z raised to power 4 by 5 factorial plus so on, right? And then we would have plus z square by 3 factorial plus z raised to power 4 by 5 factorial plus so on square and terms continuing like this. So this is our final expression. So let us now collect the similar terms. So it would be 1 by z square as such if we if we multiply this term inside. So here, can you see this term over here? So what are the terms of z square are available with us? So here if you open up this bracket, so you would only have terms of the order z raised to power 4, and here you would have z raised to power 8 squaring all these terms, and then you would have mixed terms, so it would be z raised to power 6 and terms like that. So the minimum term here is z raised to power 4, right? So let us keep this 1 by z square as such for a minute. So this thing would be 1 minus of, from here this term would be as such, right? And then the minimum term in the second expression would be that of this one. So we can collect z raised to power 4 terms. The first one is appearing over here, 1 by 5 factorial, and the second one with a negative sign obviously, and the second term here would be the square of this quantity. So the square of this quantity would be 3 factorial is 6, so that would be 36, right? And terms z to the power 6 and so on, right? So when you multiply this by 1 by z square, what we would have 1 by z square, and then it would be 1 by 3 factorial, that would be 6, and then we would have z square and this whole term. So minus 5 factorial is 120 plus 1 by 36. So we can ignore the other terms for the time being. Why? Because we only require the terms. Let us have a look at our question. So we only require either b minus 2, b0 or b2. So that means we require z square terms, or in the denominator the power is 2 or minus 3 and terms like that. So that is why I have ignored other terms. So this was the expression. So when you simplify this, you will be having 1 upon z square minus 1 by 6, and while solving this, you would have something like 7 by 360 z square plus so on. So if you compare this with your expression n varying from minus infinity to infinity, bn z raised to power n, which was given in our question. So this thing is basically equal to f of z, and this f of z is given equal to this thing. So from here we can evaluate the coefficients. If n is equal to 2, so that means we are talking about bn. So bn simply would be this term, b2 I mean, when n is 2. So b2 would be 7 by 360. Yes, and if you see this term, so this would be our b naught. So b naught would be minus 1 upon 6, right? And if you see b minus 2, it would be this term, the coefficient of this term, which is 1. So this is 1. And moreover, we do not have any term containing z or 1 by z of the sort. Therefore, the coefficients corresponding to b1, the coefficient of this term, that would be 0, and the coefficient of the term 1 by z raised to power minus 1, 1 by z raised to power 1, or you can write this to be z raised to power minus 1. So the coefficient of this term is also 0. So from here our b2 comes out to be 7 by 360, b naught comes out to be minus 1 by 6, and b minus 2 comes out to be 1. So let us have a look at our options. So from here b2 comes out to be 1, b minus 2 comes out to be 1, b0 comes out to be minus 1 by 6, and b2 comes out to be 7 by 360. So from here we would have option A as the correct option. So I hope you got this concept. Well, that is it for this video. Thank you for watching.